Hi everyone, this screencast is meant to be a brief introduction to the packet on mole ratios. So this is a way to connect mole calculations to real life things, namely how reactions work. So down below I've got 3 pictures to exemplify some ways that working with reactions and mole ratios is helpful for important real life things. So baking and recipes and being able to scale a recipe to larger and smaller batches is actually a definite real life use of using the ratios of things. A more hard chemistry example is the reaction that occurs in car airbags. There are chemicals that react when a spark is ignited in them, and it creates nitrogen gas, which is what inflates the airbag. Being able to know how much of the chemicals you need to react to inflate the airbag just enough is something that involves using calculations with moles. Similarly, being able to know just how much rocket fuel you'll need to launch a satellite into orbit is something else that would require some chemical calculations. So let's move on and actually use a starter example of how this would work. So here's a reaction of nitrogen gas reacting with hydrogen gas to produce this compound. I'm going to give you a second to see if you recall which one it is. It's ammonia. And some of you may have also noticed that this reaction isn't balanced. So pause the video and take a minute to see if you can balance it. Pause now. All right, so let's think about the best way to balance it. I believe it would be having nothing for nitrogen, 3 hydrogens, that gives us 6 atoms total, and now we have 2 ammonias. Okay, so let's focus on reading this reaction and what it means. So this, we know that there's a 1 here. I'm going to go ahead and write that in. So this could mean 1 molecule of nitrogen plus 3 molecules of hydrogen will create 2 molecules of ammonia. All right. Now, would it be valid to say that we could have 1 dozen molecules of nitrogen, 3 dozen molecules of hydrogen, and 2 dozen molecules of ammonia? If you think about it long enough, you'll see that it does make the same, it's the same reasoning. It's the same way as saying that if it takes 2 wheels to make 1 bike, it would take 2 dozen wheels to make a dozen bikes. Right? Now, would it be valid to say 1 pound or a kilogram, 3 pounds of hydrogen would make 2 pounds of ammonia? If you stop and think about it, there's lots of reasons why this wouldn't work. So these first two are correct. This one is not. And this is because of a few things. One, we know that moles and molecules of nitrogen, hydrogen, and ammonia all weigh different amounts. Another thing, if you think about the law of conservation of mass, 1 pound plus 4 pounds does not equal 2 pounds. So if we had 1 pound of nitrogen and 3 pounds of hydrogen, we should have 4 pounds of something if they all reacted together to produce a product. So this is why moles are important. Moles allow us to count the number of particles of a substance for a particular weight, and a weight that is actually manageable for us to actually measure. So let's think about it. If a dozen is like a mole, think back to our chemistry songs, then we could also say 1 mole of nitrogen plus 3 moles of hydrogen will make 2 moles of ammonia, and this is also valid. So if you are working with the counts of these substances and not their weights, then having a balanced reaction will let you be able to determine how much of each thing you would need for a full reaction. So with this, we can do lots of other calculations. So we could, if we really wanted to make 2 moles of ammonia, we would only need to use the molar mass of nitrogen and hydrogen to figure out how much of each we would need to react together to make those 2 moles. So now if you should pause for a second and get out your notes and find your mole map, and we've now got to a point where we can complete it. So with a balanced chemical reaction, we can figure out, given an amount of one substance, how much of another substance we would make. So let me write our reaction again. We have nitrogen gas plus 3 hydrogen gas molecules will create 2 ammonias. And depending on what the question is, if you're given a question, it should be clear to you from the context which of these substances would be substance A and which would be substance B. So say, like I was just mentioning, you want to make 2 moles of ammonia. How many moles of nitrogen would you need for that? Well, that makes ammonia substance A, because that's what you're starting with, and nitrogen substance B, because that's what you're going with. And figuring out which one's A and B doesn't matter. So that means we're going to go from moles of A to moles of B, and our conversion factor is the molar ratio. So what's the molar ratio? Well, it's what we've been hinting at already. It takes 2 parts ammonia to make 1 part nitrogen. So the molar ratio is 2 moles ammonia for every 1 mole of nitrogen. So that's pretty much the answer, is you need you make 1 mole of nitrogen for well, you need 1 mole of nitrogen to make 2 moles of ammonia. And then this is the very simplest kind of mole A to mole B question. You could say if you have 500 grams of nitrogen, that how much ammonia could you make? Then, and you would also be told that you would, usually in questions, you'll be told things like you have enough hydrogen or enough of the other reactant to do it. Then it's simply following the same sorts of calculations that we've done in the past, using all of the same conversion factors, except this time, if, say, I was asking for grams of ammonia, you would need to not only use the molar mass of nitrogen to go from grams to moles. We're eventually getting to grams of B here, so we would have to also use the molar ratio. So in other words, once I figure out how many moles of nitrogen this is, I'm going to know that I'll get 2 times that many moles of ammonia out of it. And then once I have that many moles of ammonia, I will have to figure out how many grams of ammonia that is. All right, so that is just a quick overview of what this is all about. Please look through the packet about mole ratios, and hopefully this will be helpful. Thank you.